Today we're going to talk about radicals, which are also known as roots. Now, what is a root or a radical? A root or a radical is the opposite of an exponent. So think about 3 squared. Now, 3 squared is the same thing as 3 times 3, which is 9. Now, remember, a radical, or also known as a root, is the opposite of an exponent. So, if I take the square root of 9, then what I'm really doing is I'm breaking up that 9 into multiples. And the multiples have to be the same number. So the only way we can do that is with 3 times 3. And we want to have groups of 2. So we have one group of 2, and that one group is composed of a 3. When you have a square root, you actually have a 2 right on the outside, but it's invisible. So you're really just making sure that you break down a number and then you find groups of 2. Some of the rules you have to remember about radicals, aka roots, are that you cannot take a square root of a negative number. Another rule you have to remember is that you cannot take an even root of a negative number. You can, however, take a cube root of a negative number. And you can also take an odd root of a negative number. So basically all of the rules in a square root have to do with negative numbers. And they'll make sense when we go over some of the examples. So if you look at the square root of 2, you want to find groups of 2, but you want to break this up into the multiples of 2. My only multiples of 2 are 2 times 1, so I can't really break this up anymore unless you find the square root and you get a decimal place, okay? So I'm just going to leave this as the square root of 2 because I can't simplify that anymore. Now, if the directions say round to the nearest tenth or the nearest hundredth, then I would plug this into the calculator and I would get 1 or 2 decimal places depending on what it asked me to do, okay? Now we have number 2, which is the square root of negative 16, and we have to come back to the first rule. You cannot take a square root of a negative number. Now, why is that? So you want to find multiples of negative 16, but those multiples should be the same number. So if I have negative 16, yes, it's 4 times 4, but one of those has to be a negative in order to get a negative 16. So that's actually not the same number. You have a negative 4 and a positive 4, and there's no combination where I can get the same number. So that does not exist. We call it an imaginary number. And you don't have to deal with imaginary numbers just yet, so we can hold off on that. Number 3, if we look at 0, a lot of students get confused with the square root of 0, but 0 is just, if I break it down, it's 0 times 0. So we actually do have a group of 2, and it's right there. So the square root of 0 is just 0. I want you to pause the video and I want you to try number 4. Now, if you just have the square root of 64, that's 8. But if you had something like x equals the square root of 64, then you would actually write x equals plus or minus 8. Because if you think about it, negative 8 times negative 8 is also a positive 64. Okay, number 5, 18, we want to first do a factor tree. So 3 times 6. And we want to break it down so that we remember we have groups of 2. And I'm going to break 6 down into 3 times 2. If I look, I actually have a group of 2 right there. And that group of 2 consists of 3. So what happens is we take out the 3, and the 3 is going to be on the outside of the square root of the radical. And the 2, since it's all by itself, it's going to stay inside. Think about it as the 3s want to go outside of the house, and they can because now they have a partner. But the 2's all by itself, so it has to stay in the house. It has to stay in the radical. Okay? I want you to go ahead and try out 52, number 6, number 7, number 8. Pause the video and come back to look at the solutions. For these examples, I want you to notice which square roots, which radicals stayed the same, and which radicals simplified a little bit further. So for example, the square root of 2 stayed as the square root of 2. And if you look at the square root of 65, it also stayed as the square root of 65. If we look at number 2, you have to remember your rules that you can't take a square root of a negative. But if you look at the rest, numbers 3, 4, and 7 were perfect squares. So that's why you have a nice whole number. But number 5 and number 6, those were reduced, but you have something on the outside of the radical and you have something on the inside of the radical. In the other problems, we had square roots, and so we wanted groups of 2. And these problems, we have different types of roots. So number 1 is a cube root, so we're going to be looking for groups of 3. Number 2, also a cube root. Number 3, also a cube root. But if you look at number 4, that has a 5, so that means they want groups of 5. Number 5, they will have a 4, so you want groups of 4. And this one, remember, number 6, if it doesn't have a number on the outside, it's just a regular square roots. We're used to square roots, so that means it's actually an invisible 2. And you're never going to see that, but I want you to remember groups of 2. Number 7 would be groups of 3, and number 8 would be groups of 5. So let's go ahead and go over number 1. So we have to think about multiplications of 8, what multiplies to 8. And we can start off by doing a factor tree with just plain 4 times 2. And then we're going to break the 4 into 2 times 2. And if we see here, we have a group of 3. And you want to look at all of the numbers that are broken down all the way. So that would just be 2. I want you to go ahead and try number 2. So pause the video really quick, try number 2, and then come back for the answer. So when you're taking the cube root or the 5th root or the 7th root, because you can have an odd number right here, just of a negative, just the final answer is a negative. That's the only difference. Number 3 looks a little complex, but you just have to do the numerator and the denominator separately. So if I look at 64, I'm going to make that a negative 64. And that's 16, negative 16 times 4. And remember, we can have a negative as long as you're taking a cube root or a fifth root or seventh root, something that's odd. The only thing is that we're going to have a negative answer. So this is going to be 4 times negative 4. And we do have a group of 3 right there. It's just negative 4. Because negative 4 times negative 4 gives me a positive 16. And then times a negative gives me a negative 64. Now let's look at 27. And I can look at positive 27 since I already dealt with the negative when I put it next to the 64. So 27 is 9 times 3. And then we break it down into, again, a group of 3. And what you do when you have two numbers, in this case, it's just one over the other. Negative 4 over 3. Notice on number 4, you're looking for groups of 5. So you want to break this down as much as you can. And I'm just going to keep going until hopefully I have a group of 5. We have 2 is a group of 5. So the fifth root of 32 is 2. Go ahead and pause the video and try out number 5 and come back and check out the answer. For number 6, I want a group of 2, but notice that we have exponents. So that doesn't matter. If I have x cubed, that's the same thing as x times x times x, which means I have a group of 2 right there, but I'm going to have an x left over. And then if I look at y to the 4th, that's the same as y times y times y times y. And I have 2 groups of y. So what happens is on the outside, you want to take out whatever had a group of 2. So we have an x, a y, and a y, and you want to multiply those together. And then we want to, any leftover numbers that we have or variables, we want to keep inside the radical. So that changes to x, y squared, square root of x. And that is simplified, even though it looks a little bit more complicated because now you have variables on the outside and variables on the inside. That's as simplified as we can get it with groups of 2. Number 7 asks for groups of 3. So we do a factor tree for 27. And actually there's a shortcut for variables with exponents. All you really have to do is take this number, 9, and divide it by whatever number you have on the outside. So this one's nice because it's easy. 9 divided by 3 is just 3, so our answer is 3q3. Now you could break it down and do q times q times q 9 times and find groups of 3 like I did with number 6. But when you have big numbers like x to the 10th power, then it's way too much writing. So you really want to use the shortcut. So this one, you have x to the 10th and y to the 5th. So we have groups of 5. So again, what you do is you just take that exponent, x to the 10th, and then divide it by 5. So 10 divided by 5 is 2. And I just have to do them separately. 5 divided by 5 is 1. And so that's our final answer. X squared over y. I'm going to erase the 1 because you normally wouldn't see a 1 right there anyways. And those are all the answers.